Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
But for today, we're going to talk about a SQL incident.
Super, yeah. The SQL incident happened on the 3rd of April. It was about 4.5 hours. It was limited to the East US region. And joining us today is we have Asad Khan, our Vice President of Azure SQL Database.
And we're also joined by Joe Ponce Galindo, our Principal Software Engineering Manager, also from the Azure SQL Database team. This is going to be a very SQL-heavy conversation. So, Asad, maybe we can start with you. Before we even get to the incident itself, I wondered if you could help give us a bit of background to help us understand some of the architectural pieces involved here. The post-incident review talked a lot about gateways. What is a gateway, and what do our customers need to know to understand what happened here?
Yeah, no, absolutely. And thank you. And thanks, everyone, for joining. So SQL is, we are talking about the Azure SQL, which is our PaaS service. It is available in 60 regions. And in each region, we have a data plane where we run the SQL database itself. We have close to 13 million production databases that we run. And all of these databases are versionless, unlike what you are used to on-prem, where it is to a fixed version, which means you don't have to ever worry about the upgrades. Every month or whenever there is a big feature available, we push the updates across the world, and all 30 million databases are upgraded. Now we have to make sure about a lot of things. Backward compatibility is one thing, but also what is the impact to the applications which are connected to these databases. So there is a lot of process that goes in. You might have heard the SDP, which is the safe deployment process, which ensures that even if there is a human error in terms of any feature that we did or any work that we did, it is caught before it impacts the production databases. So we go into the canary. There is an initial, there is a pilot, there is the heavy regions that we hit, and that ensures that the blast radius is very, very as small as possible on that one. Now, these are the data planes I'm talking about. We also have gateways in each of these regions, and there are multiple of the gateways. For example, in this region, we had 4, which ensures the connection being routed to the right database. And this is one of the key designs, because that is what gives you consistent connection. You don't have to worry on which node the database itself is running. But as you would imagine, gateways are super critical to ensure the availability for these databases, because if there is an issue in the gateway, then you may not be able to get to your database. And that's why, like, all of our databases, gateways are multi-AZ, and we have redundancy built in. And these also follow the same SDP process. So this is the quick summary, but as we get into the Q&A, I'm happy to answer any specific question.
Super, Asad, thank you very much. So you mentioned we were making a change. The change in the PIR was said to improve the management of memory. Now, you mentioned SDP. For customers who don't know, SDP is our safe deployment practices. This is where we don't make a change globally all at once, but we systematically bake it through slowly. Were we using SDP in this case when we made changes to our memory management? And was the blast radius as small as we anticipated?
Yes, so we were using the SDP, and the blast radius was small, but the key thing, and that's why we wanted to discuss this with all of you, is that we did not catch it early enough, in the sense that ideally we should have caught it in Canary, where most of the test workloads are running. We actually caught it or experienced it in one of the regions, which our ideal case scenario is that we should be able to catch it before that. So sure, it was not a worldwide outage. It was restricted to a region, and even within the region to a subset of the database. But it was big enough, something which we take it super seriously in terms of this is not one of those like where we said we would say that SDP did the right thing. Like this does caused us to go back and understand why it happened and how we can avoid it in the future.
Got it. Understood. So we were following those practices, but even still, we didn't catch it early. So I'm interested in understanding, we said in the PIR that part of the problem here was that it landed during maintenance, and that specifically in the East US region, it wasn't just regular normal maintenance, it was a particularly intense maintenance that was going on. So maybe Joe, could you help to talk us through why it was specific to this region that we saw that kind of big customer impact here, and what was unique about the maintenance in East US?
Yeah, definitely. So first of all, let me give a little bit of overview of what the gateways do. Essentially, when applications connect to SQL database in a region, those connections are received by a fleet of gateways. As Asad mentioned, we had 4 gateway clusters in the East US region. And when these connections are received by the gateways, the main function is to forward those connections to the actual target of that particular request, so to either the primary or a read-only secondary. So because due to the fact that these gateways need to route these connections to the right destination, to the right database, to the right place, to the right VM that is holding or hosting your database in our backend fleet, these gateways need to be aware of where the databases are, where the replicas are at every moment. And when changes happen, gateways also need to know that those changes have happened quick enough for any reconfiguration to not be perceived as a long unavailability event, right? So when impactful deployments, maintenance windows happen, the databases fail over from, they change VM, they move from one place to another. And when those movements happen, the infrastructure that we run or service from the service fabric, we leverage notification change event stream that is read by the gateways, as consumed by the gateways to update in real time the positions of these databases, so we can again route those connections properly, right? One of the issues that happened, or the key issue that happened during East US and why East US is in retrospective, we found that a recent change in the gateway logic was made in the path that was processing these notification events, that made this processing to be significantly slower than anticipated. And what happened particularly in East US and why we didn't catch this problem earlier and in previous phases of the SDP or in our testing was because of the fact that it required a certain number of high concurrent level of volume of reconfigurations to happen in order for this issue to trigger in the gateway, for the convoying effect to start building up, and then the latency of processing these notifications to start increasing in such a way that it was very hard for the gateways to keep up with the processing the queue of events because of the regulation that was introduced that increased the latency of processing the requests, right? So it was simply the fact of the concurrency of failovers, and that is one of the key learnings that we had acquired through this incident to improve our validation pipelines.
Super. So it sounds like as we go through this, East US provided a perfect storm of very unique conditions to trigger this event. One of the things we talk to customers about reliability and resiliency on a daily basis. And one of the things we're advocates of, we say customers with their mission critical services should think about zones and make sure that zones are there because zones can protect against many failures and faults. Would availability of zones help in this situation?
So gateway clusters are deployed in a multi-availability zone in a way that we are protected from zonal, specific zonal incidents, like when a specific dependency fails, which is sliced into a zone. For example, a storage or a compute specific zone issue. In this case, the failure that we had already, this regression had already been deployed in all the gateways in this region, right? And in particular, because of the architecture of the gateways and how we have structured the gateways to load balance the load when you connect to a particular SQL database, we have Azure Traffic Managers, load balancing requests across different gateway clusters. And then all the gateways, they need to listen from notifications from all the databases in the region. So in a way, this notification path is crossing zones, and it is more of a regional concept. So this particular failure mode is more of a regional failure, a failure that gets experienced across zones, right? Rather than a particular very specific zonal outage.
That makes sense. Yeah, so there are some failures that zones can protect against, like you mentioned, localized data center failures, power or cooling or networking. This wasn't one of those. This was intentionally a regional concept so that those gateways can handle the load balancing. That makes sense here. So now I want to pivot to the incident itself. Which of you is best placed to help me understand how we detected the issue, whether we detected it quickly, and then how our people and systems responded? What did we actually do to mitigate the problem while customers were feeling this pain?
Yeah, so this incident was detected by our automated monitoring that we have in SQL databases. So we detected within 7 minutes of the outage. One of the challenging pieces about this incident is that by the time the DRIs reacted to this incident a few minutes later after the alert, many multiple conflicting error signatures, conflicting signals were happening at the same time. So trying to make sense of all the noise around the different type of failures that were going on because of the way this incident unfolded as the queue of processing notifications increased. Then there were other failures that were caused by that. Even we were chasing multiple signals, multiple hypotheses at the same time. So it took us some time to fully understand the sequence of events that could have led to this problem, and it took us some time to understand that as this specific maintenance window was going on and correlated to the incident. So once we understood that this was correlated to a maintenance window, we proceeded to pause that maintenance window deployment on SQL database. And after we paused the SQL database, we had to take some mitigation action on all of our gateway fleet in this region in order to clear up the queue of notifications that was not being processed, the failover notifications that were not being processed, and giving a chance for these gateways to rebuild the map, essentially, of where databases are in this region.
Got it. That's helpful to understand. So it sounds like our detection was actually pretty quick. Like you said, we got there pretty quickly. The DRI, I'll help to translate our TLAs as our directly responsible individuals. So we engaged the on-call engineers pretty quickly. But then, like you said, it was really taking some time to correlate it with the update itself, correlate it with the maintenance event, and then being able to start applying some of those mitigations. So that's helpful to understand the timeline of this. We said 3-4 hour outage. So then follow-up question is we want to talk about failovers. You want to cover us?
Yeah, I know as a SQL customer, I can failover as I'm needed. There are many SQL offers many configurations of active-active where I can failover, but there's also an options where there's a managed instance failover where SQL are in charge of my failover. Could you tell us a little bit more about that and how that played a role in this incident?
Yeah, I can take that one. So as Emmy said, basically what and this is a very standard relational database concept, which is that you keep a DR instance running, which is always in sync. And in case the entire region is impacted, whether even if you are running on-prem or in the cloud, you can do a failover. Now, SQL has two variations of that. One is that the customer says, I will make a decision when I need to go and do a failover. The second is that they can say that Microsoft should decide to do the failover, and this is called the failover groups, where we will failover the entire group if we see that there is an unavailability to your database for more than an hour. So right at the hour mark, we do a bulk failover for all of those databases. And in this case, we executed that when we were close to that an hour mark.
Great. So that's helpful for the automated failovers. And then do we need is there any best practices around customers being able to do their own manual failover if they're not using that Microsoft managed equivalent?
Yeah. So and again, like we did cover in some of the other incidents as well. Majority of our databases are where the customer has taken the control, where they say we will go and decide when to do the failover. And the reason being is that in a failover group, if you have a lot of databases and we fail over the entire group, maybe that is not what you wanted because not all databases were impacted. For example, even in this case, not every database in that region was impacted. The second thing is that in many times customers want to make that decision because they also have an entire stack. They have the application layer, as an example. Now they want to do the failover of that app layer along with it so that the latency is not there. So majority of the databases that we have in production, they are configured with the DR capability where customer makes the choice. There is a subset of the databases that are configured where Microsoft will do the failover for them, and it is purely your choice. To give you a sense, the Microsoft failover are around 3 to 4% when we look at in any region, or even lower than that. So it's a very small percentage where customer configures in a way where Microsoft does the failover.
Got it. Understood. And then one final question I had on the failover. So we've talked about Microsoft managed failover. We've talked about customer implemented failover. I understand there was a bit of a hiccup with SQL managed instances that were failed over that didn't need to be. Is that right? What was our kind of learning about over failovering?
Yeah, that is right. Like basically in this case, when we saw the unavailability in a subset of the databases, and again, SQL has two flavors of the past database. There is the SQL DB as a brand, and then there is a SQL managed instance. We decided to fail over both, whereas later on, as we got into the more details, we noticed there was no impact to the managed instance, and there was no need to fail over those ones. So that did cause additional work for the customer, because when we do fail over into the different region, it is then customer choice when they want to fail back. So that was one learning in terms of we need to be more precise in terms of if the SQL is impacted in a region, we need to go to the next level and see whether it is on the SQL DB only, or SQL MI, or both.
Got it. So out of an abundance of caution, we ran too many people away from the problem. Okay, great.
Super. If we change gears and we look at our learnings and our repairs for this thing, one of the key things that we called out was we wanted to start batching deployments to prevent surges. Today, I assume that deployments are batched anyway, but are we enhancing this? What changes as we implement this?
Yeah, so the very first action that we have made is to precisely identify the particular change, the regression that caused this issue on the gateways, and we had rolled back that change worldwide, right? And we are this change. We are also as part of the learnings. One of the key learnings out of this incident was our validation pipeline. There is a gap on the concurrency level of the volume of notifications that particular types of deployments of SQL DB can have in regions as big as East US, right? So we are
Joe, I think we may have lost you, your audio. Joe, we've lost your audio. Asad, I don't know if you can step in for Joe for the repair item while we get his audio back. When we were talking about the changes until Joe comes back.
Joe, are you back or you want?
Apologies, can you hear me?
Yep.
Okay, so sorry about that. Yeah, I was mentioning that the key repair here is, well, we identified the regression that caused this problem on the SQL gateways, and we had rolled back that particular change log for of the entire fleet of SQL DB worldwide, right? At the same time, we have this issue has uncovered a validation gap in our quality pipeline related to the volume of notification, the volume of failovers that could happen on different type of Azure SQL Database deployment events. So we are covering that as well, making sure that we validate that angle of the SQL gateway scalability as well, and in a much higher number than what production has currently, right? We are also making improvements into how the gateway reacts and how the gateway can handle better these notification or these deployment volumes, right? In combination with the memory usage, which is the key thing that we wanted to improve originally as part of learnings and from observations that we had in our previous telemetry, where we originally observed that the memory of the gateway, the memory consumption was going beyond some thresholds that we felt comfortable with running. So we were doing some of those memory optimization changes, which some of those changes led to this problem, right? So we are incorporating these learnings and also improving the changes, adding this testing to these changes to make sure that this doesn't happen again.
In the PIR, we made a very bold statement which stood out to me, which there's going to be a fundamental design improvement when it comes to capacity and resiliency for the SQL service. Can you let us in on what this fundamental design improvement entails, or can you let us know more about this?
Yeah, so as part of these learnings and from other previous observations, right? So we are in a journey trying increasing and at least doubling the capacity in the gateways that we have deployed. Capacity as measured by the number of cores that we run these gateways at, right? Increasing, we have reached a point of a scalability challenge, right? With the increasing the number of cores is not as it's not as simple as just flipping a value and going from one number to the double of that. We actually need to make sure that we internally, the gateway is prepared to make the best use of this double capacity and that this is requiring us to make some changes in the way how a gateway internally processes connections to make sure that we make the most efficient use of all the capacity that we have at our hands. So this is a project that is going on, and with these incorporated learnings on the validation pipeline, we are making sure that we are going to deliver a higher quality gateway down the road.
Got it. That's a great summary. Thank you, Joe, and thank you, Asad. I think we now understand some of the short-term changes around batching to make sure that we're already protected, while some of those longer-term changes are still in progress. So good to hear both sides of that. Mindful of just our last couple of minutes here, so I want to turn the table to my co-host. Since Sammy runs our incident comms team, my last question of every retrospective: how did we do? How did we communicate with our customers? Were we able to keep people informed? What are our comms learnings?
So the good news with comms is we leverage Brain, which is our automated communication system. This triggered within minutes. So impacted customers would have had communication in Azure Server Self within moments to say, hey, it's an issue, it's an us issue, not a you issue, which usually helps appease customers and not tear down or troubleshoot their infrastructure. The gaps or the opportunities were, as the incident progressed, we had information, but because the automated communication system was telling customers who ran into impacted, they were impacted, we missed an opportunity to tell our customers where we were in the investigation, what we thought the issue was, what we were troubleshooting, and the steps we were taking to implement mitigation. The other piece that was a miss for us is it was around the managed instance part of it, where customers, we had failed them over, but we didn't need to. We didn't communicate to them very effectively, and we had to go and retrospectively tell them, hey, we failed you over. And then, as Asad mentioned earlier, that's work for customers to kind of bring that back to a normal state. But we have learnings to kind of telling the story about where we are is so important with customers to say, hey, this is what we're doing, even if we don't know. We want to tell customers, this is what we do know, this is what we don't know, and we're still looking. But yeah.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.
Thanks.